We welcome you to Glass Academy Webinars 2022-2023. The theme for this year is Ideas in Architecture, where I stands for innovation, D for design thinking, E for emerging trends, A for around the world, and S for sensitivity. Today we have with us architect Deepak Jain. Deepak is from a small town named Arnakulam in Tamil Nadu, India. Being well known for locomotives, the place was always bustling with rails moving about. This nurtured a fascination in him for railway tracks and networks. The flexibility and movement of the changing tracks were always something that grabbed his attention. This, he believes, instilled an early interest in making handmade models in awe of concept of flexible spatial design. 5 years of architecture school honed his interest, supplemented with a wide range of subjects. 3 years of his professional experience taught him to tackle situations at site and the process from design to breaking ground reality. In his master's at KU Leuven, which has been an incredible journey for him, he has designed a bioclimatic school in Morocco to rehabilitating the grain silos in Portugal and so on. Currently, he's working at Maker Architect in Belgium and focusing on creating circular and flexible buildings for future. 10 years of his architectural journey has made him keen in developing spatial configurations which are flexible, modular, adaptable, with circular building strategies. Welcome, Deepak. We are delighted to have you here with us and we are looking forward to your presentation. Let's hear from you on the topic architecture in Anthropocene building circular. Over to you, Deepak.
Good afternoon, Priyanka, and thank you, Timitos, for having me aboard on this webinar session. I would like to I'll start presenting. Okay. So today I'm going to talk about building circular in the age of Anthropocene, how we can build circular buildings in this times. So I'm going to talk about a few concepts of how you can build circular, and then share two of our projects at Marker Architecting, uh, which involves in building circular strategies. I'd like to start my presentation with two of the images by Edward Brinsky, where he shows the where he portrays the insatiable human appetite for the world's raw materials by the humans. And these images showcases us how human activity has adverse effects on the environment and the climate. And as an architect, it always made me question: is this the only way to source raw materials for the building industry, or there is an alternative approach where we can source raw materials in the cities and the infrastructure which we have already built now itself? So, for me, I have a feeling that the cities and the infrastructure which we have already built can act as urban mines. For example, a site or a building which is going to be demolished can act as a material bank, which can provide new materials for the new building to be built. So, how can architecture be circular? There are three important aspects to understand to build circularly, I think. The first is to understand the potentials of the existing building, whether you have to maintain, reuse, or repair or renovate. And the second aspect would be to design the spaces in a flexible and a modular way so that it can always have the feasibility of going it reversing the spatial and technical installations in a building as well, and then also maximizing the reuse of building products and materials which are present at the site itself. To unfold the complexity of the building, I would use the sharing layers theory by Frank Duffy, and which was later elaborated by Stuart Brand in his book How Buildings Can Learn. So the layers theory is a set of integral components that adapt or change with the time scale of the buildings. So this consists of six different layers: the site, structure, skin, services, space plan, and the stuff. The site is always existing in the environment, as we know. And when we build a structure, it is generally a robust structure which lasts around 30 to 300, 30 to 100, or sometimes also in a heritage site, it lasts around 300 years. And the skin generally adapt or change within a time course of 20 years or so, due to like a change in an aesthetical or a technological advancements in the facade, or to renovate or repair the facade as such. And then the services in a building, which are like electrical, plumbing, air conditioning systems, they generally worn out between 7 to 15 years in time. And then there's the space plan, which is the interior layout of the building, which involves the floor, walls, and the ceilings itself. They In a commercial turbulent commercial space, generally they change or adapt within 3 years or so, but in a quiet home, the space would change between 10, 15, or 30 years in sometimes. And then the last layer is the stuff which we put in these spaces, which are like chairs, desks, lamps, or plants and things like that, which adapts with which adapts very rapidly, I would say. So I would say these if the buildings are designed with these six layers in mind, it would be easily adaptable or modified in the future, and also it prolongs the longevity of the architecture itself. And now I'm going to present the first project by Marker Architect in Gen in Antwerp in Belgium. It is called the Zerene. And it is the conversion of an old medical archive into office spaces. So this the conversion involved two superimposed floors, as you see in the image. Each space was about 420 square meters each, and we had to convert this medical archive into an office space. Uh, and the second image shows how the robust structure, the existing robust structure with columns and beams in concrete. And this gave us an the rational construction allows us the rational construction of columns and beams with a 3 meters 60 allows us to create a modular layout inside the office space. And the central elongated horizontal shaft is been used to use as a technical horizontal shaft, which acts as the backbone of the office itself. And then the the spaces around the shaft were designed in such a way that it can be sometimes an individual office or an individual conference rooms, or to have an open office plan as such. So these were done in terms of scenario planning for the client, how he wanted to use the office spaces according to his needs. This is a section of the two superimposed floors in which where you see the horizontal shaft, which where all the technical installations have been set in, which acts as the backbone for the entire office in the space. In the technical shaft, there are like things which has for ventilation, uh, fire sprinklers, motion detectors, and things like that. The central long elongated technical tube gives us the feasibility to place the sprinklers, smoke detectors wherever needed without doing larger modifications at the site. So the client can decide whenever he wants how he want to adapt the space to his needs according to the times. This is a picture taken during the construction of the interior space. The central, as you see in the picture, the central horizontal shaft has all the technical installations, and the office spaces are enclosed around it. So the four main strategies in the conversion of this was there were four main strategies for the conversion of these medical archives into the office spaces. The first was to maintain the robust structure as it is, just to do basic maintenance or repair wherever required in the existing structure. And the second was to recycle and reuse the floors and the ceilings as it is. And the third was the interior partition walls, which was designed on a 90 centimeter module, so that it can form various sizes of spaces inside the robust structure itself. And also these partitions has has a set of components which consist of profiles, connecting systems and low tech connections, so that they are easily disassembled and reused in the future if needed. So the entire strategy was to create a set of systematic solutions, I would say, for partitions, ceilings, and technical installations, which are adaptable and also built with the use of reusable, sustainable materials at the same time. So all these low aluminum connect profiles were made with very low tech connections, so that it was there was a possible scenario if they want to disassemble in the future. So we worked closely with Alumis to find a system where you can dismantle easily in the future as well. As you see in this image, the profiles are made in such a way that these bolts and these low tech connections can be easily dismantled whenever if they don't want to have the space, or they want to adapt it as they want. And these are some of the pictures of the site finished. As you see, the recycle floor, glass partition walls, and the 90 centimeter modules where sometimes it becomes a door to act as a uh, to segregate the space and also act as an entrance for the space itself. And in this image, you see how the horizontal technical shaft helped us to place the mechanical ventilation, smoke detectors, and sprinklers into the space. And then the client would decide however he wants to adapt the space and use it as per his needs. Also, the exterior of these medical archives was designed on the similar terms, so that it is easily dismantleable or disassembled when not needed, or if you want to upgrade the facade itself in the future. And moving on to the second project, which is a social housing project called Deestrat, which is in Kortrijk in Belgium. It's a social housing neighborhood where we had to come up with the solutions to redevelop this neighborhood. And when visiting the site, there were a lot of buildings were found which were not suitable to be reused. due to structural or comfort requirements as such. So, a set of 12 buildings were selected to be demolished. Uh, so, this is a model which shows the master plan and the buildings which are to be demolished on site. And uh, so, the demolition of these buildings would have a lot of construction waste, but the strategy was to try to recuperate as much as materials from these demolished sites itself, so forming a material bank for the new construction itself. So we try to recuperate a maximum number of bricks and roof tiles which can be used in the new construction again. Here you see how the contractor took an took took an extreme effort to dismantle reusable roof tiles, and then he stacked into small crates, uh, which can be used later for the new construction again. And in the same way, the dismantle of bricks was done, so that it is treated and tested for the reuse of the material itself. And by demolishing all the buildings, we could recuperate around 167 boxes of bricks, and they were segregated in terms of quality, which certain bricks would be able to use as a facade, or broken chips would be used in terms of like gabion walls, or rubber, or some places where it forms a horizontal band of parapet wall, things like that. So the estimated recuperations of these bricks and roof tiles were around 50%, but after recuperating, due to the contractor trying to still put a lot of effort to recuperate, we could reuse around 32% of the bricks and 61% of roof tiles, which I still think it's a decent effort by the contractor. And once the bricks and the tiles were recuperated, the next step was to test it if we can really use it for the new construction. So these materials were marked and sent for test to Wienerberger to test the impermeability, compressive strength and density, and the durability of the tiles and the bricks. The bricks had a good durable compressive strength which could be reused again, and also the at the same time the roof tiles had to be treated a bit, but it could be reused again in the new construction. So this is a reuse strategy for their start. Like in the existing situation, we demolished, we recuperated the bricks and the tiles, we stored it at a place close to the site, and then it was used in terms of like gabion walls, or the facade itself. And then to reuse these bricks, we have a lot of testing with different mortars, so that it also allows us to disassemble in the future again if needed. I hope that situation wouldn't arrive, but it's always better to design um, for the future, I would say. So the contractor took a lot of effort to build mock-ups where he would build the facade system with different mortar joints, and also at the same time build it, keep it for a few days and break it, and disassemble the brick facade again after a few days, to show the flexibility to the client as such. And then so after recuperation, the design strategy was to use this in the itself. So also creating a form in the facade with the reused and the new bricks, because the recuperated bricks were not fully enough for the new construction. So the facade of this new construction itself was formed from the reused and the new bricks, which in a way has a new meaning given to the old recuperated bricks, but keeping the essential of the site still at the in the new construction. So this brings me to the end of my presentation. Mm, thank you.
That was a wonderful presentation. Thank you for taking us through your architectural journey and learnings and enlightening our audience with the concepts that will help build a better future. I'm sure our viewers have a lot of takeaways from your presentation and must be curious to know more, including myself. I would like to take this opportunity to ask you a few questions. So the first question is, how can architects and contractors bring the change together to build the circular?
Um, this is it's a challenge where architects face when you have to come up with these kind of design solutions, I would say, because convincing a client to reuse the same materials again in a new construction is something not all clients would really agree to it. Especially, I can understand in our context, it's very difficult, but by showing the right examples, by showing the potentials of the materials itself, I think we can find a decent balance to try to uh, build circular in a way.
Okay, so you covered the next question also. So we have the last question. Other ways of architecture contributing to the circular economy.
I feel architecture can contribute to the circular economy in different scales. Uh, like uh, in the city where I live in Kent, uh, they form like local neighborhoods to produce their own, like having urban gardens, producing their own food, having solar panels in the roof, having a geothermal system, uh, producing a circular energy system to the grid itself, and sometimes also by composting the food and producing biogas in their gardens. So I think architecture can play a different, if you provide the means and the ways uh, to towards the circular economy. It's the client, or the user will always find a way uh, to produce something for to be circular in a way, I think.
Yeah, that's like, yeah, correct. Architecture can contribute to the circular economy in those ways. So thank you so much for enlightening us through your presentation. And I think with that, we can sign off.
Thank you so much.